Hello guys, we want to talk about part 2 of rotational motion. And in this chapter, we'll be looking at purely moment of inertia. So when we are talking about moment of inertia, which can also sometimes call the second moment of mass, is defined as the product of mass of the section multiplied by what? By the square of distance from the section. Meaning that what? If you want to write it mathematically, you can write moment of inertia as what? Mr square. So that means the product of mass and the square of the distance between the what reference point or reference axis and the center of what of the section involved. So and there are factors that also affect. Now don't forget mass also can affect it, moment of inertia. That's why you must what there are factors that plays a vital role or that play a vital role in the what affecting moment of inertia whenever you are dealing with them. For example, the distribution of mass within the body can also what affect. That's why we ensure that whenever you arrange the body, all the masses to have a common what distance. Maybe for example, you have what? This is a body now. Mass here M1, M2, M3, M4. Let's say this is the centroid from here to this place to this place to this place. Now, if you arrange all these masses to have a common distance, that distance so that they will now rotate about that from the axis of rotation to that distance, we have a common distance. That common distance that all the masses that are distributed have is what we call radius of gyration. That means what I'm saying is that M1 has this is a point mass, have a distance from this centroid. So this is a reference point, this is center of gravity of the body. Now from this point to this point, I have M1, from this R1, from this point to what? To M2 is R2, like that, R3, R4. Now this R1, R2, R3, R4, you arrange it in such a way that the R1 is equal to R2, equal to R3, equal to what? K. This K now, for them to now have a common distance whereby they will now rotate about that distance, about the center from that, using that distance is what we call the radius of gyration. And I just told you that the mass of the distribution or the distribution of mass within the body also affects center of moment of inertia. Another thing that affects moment of inertia is the shape of the body. Very important. If it's check, I've drawn some shape on the body. We should be looking at the moment of inertia. So the shape of the object also affects moment of inertia. Different shapes have different moment of inertia. And this moment of inertia are the formula is influenced by the kind of shape that they possess. The next one is the perpendicular axis of rotation. That means that this is the axis of rotation. And if you check this axis of rotation, it is perpendicular to the shape of the body. Always must be perpendicular. If you check this one now to this end now, or is perpendicular to what? To the shape of the body. So you must ensure that you draw a perpendicular line that will be perpendicular to the body in or the section, so that we can know that's why I say the perpendicular axis of rotation, the shape of the object, and distribution of mass within the body. Those are the three factors that affect moment of inertia, and we have defined moment of inertia as a product of mass and distance squared. And the distance must be between the reference axis and the center of the section or the body involved. Now, having done that, now somebody might say, what is the reference axis? This is the point, center of gravity, which is the gravitational weight of the body tends to have. We call it center of mass in this case. So centroid here, from this center to the point of reference. This point of reference is what we call the distance. So if you square the distance multiplied by the mass in question, you have gotten the moment of inertia. And the moment of inertia of a point mass, that means what I mean by, if you have a point here and this is the body of reference. Now this one has a mass of what? M, having a distance from here So this point of what we are taking this point as centroid of the section. Then this is the mass of the body. From the center to the reference body of the body is R. Let's say is R. So the moment of inertia of this body will now be what? mr square. The mass times the distance square. That is how to find the moment of inertia, which we will have defined like that. Now, having defined the what? The moment of inertia, let us now look at shapes of body. We have talked about what shape of the body affecting what the factor that affect moment of inertia is shape of the body. Now we pick a shape and we begin to analyze the shapes of different body one after the one that are common. There are so many of them. In fact, let's start with rod. A rod is what? Something like we just represent with a diagram. Let's say with a length of L. Length of L. We want to find the center or the moment of inertia about its center. This is G. We can call it IG. Anytime you say IG, it means about the center. And that will give us what? 1 over 12 ml square. 1 over 12 ml square. Now, 1 over 12 ml square is the moment of inertia of the rod about its center and perpendicular to what? To the rod itself. Now, this is what can also be equal to mk square. Please take note of that. All shapes are equal to mk square, where k is radius of gyration. I've told you, radius of gyration is the what can be achieved when you have different masses. I've told you that are arranged on the body. Now you now give all those distances of these masses, you make them equal. You ensure that they have an equal distance that will now be equal to the what radius of gyration, meaning that r1, r2, r3, r4 all equal to k, so that they can now have what a radius of gyration. And don't forget, radius of gyration is not affected by what? By shape of the body. It will remain mk square for every shape of the body, whether at the end or at the middle. What about the what? At the ends of the what? Of this body, a rod. It will be what? We want to solve, you can solve with this formula Ig plus mh square. This is the point. This is h. Your h is half length. So this one is 1 over 12 ml square plus what? M times what? What is your half length from here? If everything is L, your half length will now be what? L over 2 all square. If you add them together, you would have ml square over 4 plus ml square over 12. We are going to have what? 1 over 3 ml square. So that is how we arrive. We use what they call the parallel axis theorem. This is what we call the parallel axis theorem. It is used to calculate the moment of inertia on the body or outside the body at any position of the body, which is what? ml square. So use that formula, you are going to have that. Then this one about the center is what? Ig for what? Solid cylinder. It is 1 over 2 mr square. I just pick important word shapes and the word for relevant for professional for advanced questions, maybe for A-level students, so that we can be familiar with it. Then another thing again for solid sphere, the moment of inertia of the solid sphere is 2 over 5 mr square. 2 over 5 mr square. Take note of that. 2 over 5 mr square for a solid sphere. Why for what? For spherical what? We have what? Spherical shell or thin wall hollow sphere. We have it as what? 2 over 3. You have 2 over 3 mr square. You have similar what? Formula. Moment of you must put all this formula on your head. For hoop or for thin ring or for thin what? Cylinder or for a cylindrical ring or for a what? A hoop. About the center is what? Mr square. Mr square. You understand me? Mr square. Maybe later on I will tell you different. We can have about its the tangent perpendicular to the plane. We can have about its edges. Those ones, and we can have it 2 mr and all that. We can have it as 1 over what? 2 mr square. It is possible. So, but the major one is what I'm just talking about its what center. Now, concerning the slab will what have is what about the center is what 1/12 m into bracket what a square plus what b square about the center. Now, I want to show you something. What if I want to take it about this end? About its end. I want to take it about this end. If I want to take about this side, what a, it will now be what I will now be equal to. We now use this full length. I have 1/12 m b square about the ends of b. That means this side. If I want to consider what about this side, it become 1/12 m a square. And if I'm taking this side, because if you look at it now, look at what now happen. If I have something like this, look at it. This one now, it now be what? B. Here is now A. Let me draw it like this. If I want to take moment of inertia about this end, that side is already what is not perpendicular, rather it's parallel. That's why we say it must be perpendicular axis of rotation. So in that case, we want to calculate moment of inertia about this end. I will use what I equal to let me change my marker equal to 1/12 what b square. 1/12 what mb square. If I now want to consider this other side, let's say I want to consider what, let's say this other side, I want to consider this b and this a. So I want to calculate what moment of inertia about this end. It now become I equal to 1/12 ma square, because this one will now be, it's like you have fixed this end. So here will now be what ma square, because this line parallel to this b side, it must be a perpendicular axis to that what we are considering. Now the next one that we want to consider is what hollow cylinder. Hollow cylinder. Hollow cylinder. I just analyze that one. If I have something like this, look at the board, a cylinder like this. Let's say we have a rough sketch, a hollow cylinder like this. Now, from this center of what we have R1, then from this to this way R2. From the center to this end is internal radius, the external radius. How do you calculate the moment of that what? Hollow what? Cylinder with two radius. The two radius R1, R2. It will now be what? I will now be what? 1/2 m into bracket what? Now be R1 square plus what? R2 square. This is what moment of inertia of a hollow cylinder. Hollow cylinder. Let's see whether there's other what shapes that we have not talked about. We have talked about slab. This is slab. We have talked about slab of two sides, about its center or through the center perpendicular to the what? To the slab. We have talked about a solid what? Now, we've not talked about a solid disc. Okay, I've talked about solid disc. Okay, solid disc is what? The same thing as solid wheel or solid cylinder, which is 1/12. So we've talked about majority of what? Of the moment of inertia we are supposed to talk about. So this is like number 7. And I'll be able to explain to my best of knowledge what basic thing that we need not to complicate it. So far so good, we are able to explain moment of inertia of different shapes, and we are able to define moment of inertia as sometimes called the second moment of mass as what? The product of mass and the distance from the reference point to the center of the section. We have also talked about the factors that affect moment of inertia, which are what? The perpendicular axis of rotation. We have also talked about the shape of the body, which is very paramount and important. We have also talked about the what? The mass distribution or the distribution of mass within the body. And I've talked about radius of gyration. Don't forget all these formula, all equal to what? Radius of gyration. Don't forget all of them are all equal to radius of moment of inertia as a result of radius of gyration. This is what? MA square. Here is what MA square. Here is what MA square. You understand me? MA square. So it gives them what the ability to rotate. So at the point of moment of at the point of what radius of gyration, the body rotates freely. It rotates freely. If you put your hand on a particular circular object and you turn it around, it begin to rotate freely about it as that point where your hand is, as we assume that all the masses have a common distance from that point where your hand, the center of axis of rotation is, where that your hand, that your finger is. So they now have, it's like all the masses on the body what now have a common distance, a common what distance that are equal. So that point is what we call the radius of gyration. We have talked about the shape, we talk about solid rod, which is 1/12 about the center, 1/12 about each center perpendicular to the rod. We have talked about 1/3 ml square for about the ends. So you can differentiate about the center is 1/12 ml square, about its end is 1/3 ml square. We have talked about a solid cylinder, 1/2 ml square, where R represents the radius of the what cylinder from the center. We have talked about what also solid disc or solid wheel can be likely to be that. We have also talked about what a spherical shell, a thin wall spherical shell, which is for 2/3 spherical sphere, which is what the same thing as what 2/3 mr square. We talk about solid what sphere, which is what 2/5 mr square. We talk about hoop or a cylindrical ring or a thin ring, which is also known as mr square. We have other, you can find it at the edges of the wall, you can find it at the tangent of it, but I just give us the common one. Then we can have the moment of inertia of the slab, which is what 1/12 m open bracket a square plus what b square, where a and b are side length. Don't forget that if this slab were to be a square slab, there will be a difference. A will be equal to what? B. Because if it's a square slab, A and B are equal. Then if A and B are equal, what happens? It become what? A square plus A square over 12 times m, which will now give us 2A square, and 2A square can cancel out. We have m over 6A square. That means MA square over 6 will be for a square slab. This is a rectangular slab about its center. So take note of that. We have also talked about what a hollow cylinder with two radius. So till next, when we shall meet again, same channel, please ensure you click the like button and what subscribe to what always watch us. Those of you that are returning viewer, thank you for watching. God bless you. Have a wonderful day. See you in my next video.